Okay. In the previous video, we looked at an intuitive method for solving rational inequality. Now we're going to look at a much general method. The analysis that we did with our intuitive method depended on just finding out where the numerator equals 0 and where the denominator equals 0, and then looking at that gives us information about where it's positive and where it's negative. So for fx less than 0 or fx greater than 0, we first find where it is equal to 0, just like in the polynomial case. Find x for which the denominator is 0 as well. Right, so find where numerator and denominator are both 0. This makes a line divide into 3 regions. You pick a test point, plug it in, find the sign, and you report the region. So it's exactly the same as polynomial. The only thing you have to be careful about is that the denominator cannot be 0, right? So no matter what, you can never include the, for example, 7 in this case, because it's not even in the domain of the function. Okay, for example, some modifications here. Now you have a number, which means you need to do a little bit of something from what we learned before, which is simplifying rational functions. So on the top, you have a negative x. What's that? 1 minus 6 would be negative 5. Now again, a little bit of something that we learned before, which is I can make all of this positive. When you multiply an inequality by a negative sign, you have to flip the inequality. So now this becomes less than 0, right? Because multiply by negative 1. All right, so my points are negative 5 and negative 3. Then my test points are going to be 0, negative 4, negative 6. Now f of negative 6, again, I don't have to find the actual value, right? That's negative 1 over negative 3, which is positive. F of negative 4 is going to be negative 4 plus 5 over negative 4 plus 3, which is positive over negative, which is negative, and f of 0 is 5 over 3, which is positive. So redrawing the regions, what I have is negative 5, negative 3, positive, negative, positive. So the solution is the region in between. And there's an equality sign here, which means I can have negative 5, but I can never have negative 3, because that makes the denominator 0. So I can never have negative 3. Now last example here is when you have two rational functions and you're trying to find when one is greater than the other. Basically what you have to do is you have to bring everything to one side, which means this is going to require you to solve or simplify these rational functions which we have learned before. Greater than 0, so that's a 3x minus 6 minus 3x minus 9 over a nicely factored form in the denominator, greater than 0, which causes the 3x to cancel out. So you have a negative 15 over x plus 3, x minus 2, greater than 0. Again, you can get rid of the negative sign by multiplying by negative 1. Now you don't have anything in the numerator, but you still have two things in the denominator, so we use them. Pick the test points to be 0, 3, negative 4. Now f of negative 4 is 15 over negative 4 plus 3 and negative 4 minus 2. This is negative, this is negative, so the whole thing is positive. F of 0 is 15 over 3, negative 2, so it's negative. And f of 3 is 15 over 3 plus 3, 3 minus 2, both of which are positive, so it's positive. So in conclusion, what we have negative 3, 2, positive, negative, positive. Again, now here, Well, also because it's less than 0, we do not include the endpoints, but also because we cannot include the endpoints. Right? So the solution would be -3 to 2. Okay, that's it for this week.